And thank you all for coming. This is a great crowd. And I want to welcome Dr. Matthew Walker. He is professor of neuroscience and psychology at the University of California, Berkeley. And he is the founder and director of the Center for Human Sleep Science. And he's here today to talk about his new book, Why We Sleep. So without further ado.
Thank you very much, Josh. Thank you. Well, it's a delight and privilege to be here. And I would like to start with testicles. Men who sleep 5 hours a night have significantly smaller testicles than those who sleep 8 hours or more. In addition, men who routinely sleep 5 to 6 hours a night will have a level of testosterone which is that of someone 10 years their senior. So a lack of sleep ages you by a decade in terms of that aspect, that critical aspect of wellness and virility. And we see equivalent impairments in female reproductive health caused by a lack of sleep. This is the best news that I have for you today. From this point forward, it's only going to get worse. Rather than tell you about the wonderfully good things that happen when you get sleep, I'm going to tell you about the alarmingly bad things that happen when you don't get enough, both for the brain and for the body. Let me start with the brain and the functions of learning and memory. What we've discovered over the past 10 or so years is that you need sleep after learning to essentially hit the save button on those new memories so that you don't forget. So sleep essentially future-proofs those facts within the brain. But recently we've discovered that you not only need sleep after learning, you also need sleep before learning. But now to actually prepare your brain, almost like a dry sponge, ready to initially soak up new information. And without sleep, the memory circuits of the brain effectively become waterlogged, as it were, and you can't absorb new information. So here in this study, we decided to test the hypothesis that pulling the all-nighter was a good idea. How do you do that? Well, we took a group of healthy adults and we assigned them to one of two experimental conditions, a sleep group and a sleep deprivation group. Now, the sleep group, they're going to get a full 8 hours of shut-eye, but the deprivation group, we're going to keep them awake in the laboratory under full supervision. There's no naps, there's no caffeine. It's miserable for everyone included, us as well. And then the next day, we're going to place those participants inside an MRI scanner. And we're going to have them try and learn a whole list of new facts as we're taking snapshots of brain activity. And then we're going to test them to see how effective that learning has been. And that's what you're looking at here on the vertical axis, the amount of learning. So the higher up you are, the more that you learn. And when you put those two groups head to head, what you find is a quite significant 40% deficit in the ability of the brain to make new memories without sleep. And I think this should be frightening considering what we know is happening to sleep in our education populations right now. Just to frame this in context, it would be the difference between acing an exam and failing it miserably. And we've gone on to discover what goes wrong within your brain to produce these types of learning disabilities. There is a structure on the left and the right side of your brain called the hippocampus. And you can see it here in these sort of orange-yellow colors. Think of the hippocampus like the informational inbox of your brain. It's very good at receiving new memory files and holding on to them. And when we looked at this structure in those people who'd had a full night of sleep, here in green, we saw lots of healthy learning-related activity. Yet in those people who were sleep deprived, we actually couldn't find any significant signal whatsoever. It's almost as though sleep deprivation had shut down the memory inbox And any new incoming files, they were just being bounced. You couldn't effectively commit new experiences to memory. And parenthetically, I should note, if you would like to know what life is like without a functioning hippocampus, just watch the movie Memento. I suspect many of you have seen this, but this gentleman suffers brain damage. And from that point forward, he can no longer make any new memories. He's what we call densely amnesic. The part of his brain that was damaged was the hippocampus. And it is the very same structure that sleep deprivation will attack and block your brain's capacity for new learning. So that's the bad that happens when you take sleep away. Let me just come back to that control group for a second. Do you remember those folks that got a full 8 hours of sleep? Well, we can ask a very different question here. What is it about the physiological quality of sleep when you do get it that actually enhances and restores your learning and memory ability each and every day? And by recording sleep with electrodes placed all over the head, we've discovered that there are big, powerful brain waves that happen during the very deepest stages of sleep that have riding on top of them these spectacular bursts of electrical activity called sleep spindles. And it's the combined quality of these deep sleep brain waves at night that acts like a file transfer mechanism. It takes memories from a short-term vulnerable reservoir and shifts them to a more permanent long-term storage site within the brain called the cortex, this big wrinkled massive tissue that sits atop of your brain. And it means that when you wake up the next morning, there are two benefits. First, having shifted memories of yesterday to that long-term safe storage haven in the brain, they are protected so that you will remember rather than forget. The second benefit, however, is that having shifted those files from that short-term reservoir, almost like moving files from a USB stick, you've cleared out all of that memory encoding capacity so that when you wake up the next day, you can start acquiring new files all over again. You can start learning anew. So it's this elegant, beautiful symbiotic system of memory that happens each and every night. And it's important that we understand what, during sleep, actually transacts these memory benefits, because there are real medical and societal implications. And let me just tell you about two areas that we've moved this work out into. I'll begin clinically, and specifically the context of aging and dementia. Because I think many of us have a sense or even know that as we get older, our learning and memory abilities start to fade. They begin to decline. But what we've also known for many decades is that a physiological signature of aging is that your sleep gets worse. And not just any type of sleep, especially that deep quality of sleep that I was just describing. And only last year we finally published evidence that these two factors are not simply co-occurring, they are significantly interrelated. And it suggests that the disruption of deep sleep is perhaps an underappreciated factor that is contributing to what we call cognitive decline or memory decline in aging, and most recently we've discovered in Alzheimer's disease as well. Now, I know this is remarkably depressing news. I understand it's in the mail, it's coming at you. But there is a potential silver lining here. Because unlike many of the other factors that we know are associated with aging and dementia, for example, changes in the physical structure of the brain, or even changes in the vasculature of the brain, those are fiendishly difficult to treat right now. And we don't have any good wholesale approaches in medicine. But that sleep is a missing piece in the explanatory puzzle of aging and Alzheimer's is exciting because we may be able to do something about it. And one way that we are approaching this at my sleep center is not by using sleeping pills, by the way. They are blunt instruments that do not produce naturalistic sleep, and they've been associated with a higher risk of death and cancer. And I'm happy to speak about that evidence during the Q&A, and it's discussed in the book as well. What we are actually doing is developing a method based on this technology. It's called direct current brain stimulation. It sounds like the stuff of science fiction. It's actually science fact. You apply electrode pads to the head and you insert a small amount of voltage into the brain. So small that you tend not to feel it, but it has a measurable impact on physiology. Now, if you apply this stimulation during sleep in young, healthy adults, as if you're sort of singing in time with those deep sleep brain waves, not only can you actually amplify the size of those deep sleep brain waves, but in doing so, you can almost double the amount of memory benefit that you get from sleep. The question now is whether we can translate this same affordable, potentially portable technology into older adults and those with dementia. Can we restore back some healthy quality of deep sleep? And in doing so, can we salvage aspects of learning and memory function? That is my real hope now. That's one of our moonshot goals, as it were. I should note, by the way, because I always get asked this question, people will say, where can I buy one of those devices? I want one yesterday and I want 5 more tomorrow. They are not yet FDA approved for use in sleep. You can buy them on the internet. I strongly advise against that. Just read around some horror stories. People have misaligned the voltage, skin burns, they've lost their eyesight for several days. Hang on. We are desperately trying to bring this to fruition as soon as we can. So that's sleep and memory in a clinical context, but let me speak about sleep and memory in society, and specifically here within education. Because if sleep really is so important for learning and memory, then enhancing sleep in a context where arguably it matters most should prove transformative. And it has, because there are several counties throughout the United States that have started to delay their school start times and then measure the academic consequence. Now, one of the earliest test case examples happened in Adena in Minnesota. It's a township that sits just outside of Minneapolis. And they shifted their school start times from 7:25 in the morning to 8:30 in the morning. By the way, what are we doing trying to educate our next generation at 7:25 in the morning? To give you a sense of this, buses for a 7:25 start time will often begin leaving at 5:30 in the morning. That means that some kids are having to wake up at 5:15, 5 o'clock, maybe even earlier. This is lunacy. But in Adena, it was the beginnings of a movement. And the metric that they used to assess the academic consequence was this, SAT scores. And they focused their analysis on the top 10% performing students, arguably those that have the least to gain in terms of any further improvement by way of sleep. Now, in the year before they made the time change, that top 10% performing students got an average score of 1,288, which is a very respectable score. The following year, when students were now going to school at 8:30 in the morning, the average SAT score was 1,500. That is a 212-point increase, which is non-trivial. That will change which tier of university those school kids end up going to, and perhaps as a consequence, their subsequent life trajectories. Now, some people have questioned aspects of the Adena study, and I think for perhaps good reason. But in all of the subsequent carefully controlled studies, the data is unequivocal, I think. Academic grades increase, behavioral problems decrease, truancy rates decrease, and psychological and psychiatric issues also decrease. But something else actually happened in this story of later school start times. And it was something that we did not anticipate. The life expectancy of students actually increased. And you think, I don't understand, how does that work? Does anybody know what the leading cause of death in late-stage teenagers is throughout most developed nations? Suicide is actually second, it's car crashes. And here, sleep matters enormously. Another example comes from Teton County in Wyoming. They shifted their school starts from 7:35 in the morning to 8:55 in the morning. And then they measured the reduction in car crashes in this narrow age of just 16 to 18. The only thing perhaps more remarkable than the extra hour of sleep that those students reported getting was the drop in vehicle accidents. There was a 70% reduction. Just to sort of frame that in context, the advent of ABS technology, what we call anti-lock braking systems, that prevent your wheels from locking up under hard braking so that you can still safely maneuver a vehicle, that dropped accident rates by 20 to 25%, and some deemed it to be a revolution. But here is a biological factor, sleep, that will drop accident rates by up to 70%. I think it's time for us to reconsider the importance of sleep in education. When sleep is abundant, minds flourish. And if our goal as educators truly is to educate and not risk lives in the process, then I fear that we may be failing our children in a significant manner with this incessant model of early school start times. So that's sleep for learning, memory, aging, Alzheimer's. What else is sleep good for? Let me tell you that sleep is essential to help stabilize your emotional and mental health. And without sleep, the emotional circuits of your brain become hyperactive and irrational. Allow me to demonstrate with a sleep-deprived subject, because it turns out that we do video diaries with our participants throughout the deprivation night. And you're going to meet one under the pseudonym of Jeff. It's 11:30 at night. Jeff has been awake for about 16 hours, and I'm actually just going to plug in the audio here to see if I can get you some audio playing out. Jeff's just entered the study. He's been awake for a normal 16 hours. And perhaps let's hear from Jeff what his sort of hopes and aspirations are for the deprivation period.
Hello. It's about 11:27 right now. I've been here for about I think about an hour. No. Yeah, about an hour. So it's the first hour. I'm writing my paper right now, 30-page paper. Hopefully I can get some of it done before I get too sleepy.
So that's Jeff, a perfectly likable, affable chap who's hoping to get his 30-page report complete in a night of sleep classic delusional undergraduate thinking, I have to say. I see it all of the time in my students. So now let's fast forward the clock. It's now 5:30 the following morning. Jeff has now been awake for 22 hours straight. And instantly you'll notice one of the hallmark features of sleep deprivation, which is that you actually slide down in your chair. You can look around the room right now actually and see. Jeff's down about 6 or 7 inches. It's about an inch for every hour that you've been awake beyond the standard 16 based on our highly sophisticated machine learning algorithms. But in all seriousness, notice how emotionally different Jeff has become. Some people have, I think, perhaps unkindly described him as becoming a little bit emotionally unhinged. So let's hear how that 30-page report has been going. And I do apologize ahead of time for the profanity.
Hello. I'm very angry right now. Because I didn't get any fucking... But can I curse on this? I think, whatever. They probably think I'm crazy. I'm very lucid, actually.
So did you notice how Jeff went from being remarkably upset and annoyed that he got none of his 30-page report complete to then finding it almost hilarious? He was nearly sort of punch-drunk giddy on sleep deprivation and then came right back down to baseline again. That is a remarkably abnormal emotional distance to travel within such a short time period. And I think it emphasizes the type of destabilizing influence that a lack of sleep has on our emotional integrity. And we've since discovered what actually changes within your brain to produce this type of pendulum emotional irrationality. There's a structure very deep within your brain called the amygdala, and you can see it here in these red colors. Again, you have one on the left side and one on the right. And the amygdala is one of the centerpiece regions for the generation of strong emotional reactions, including negative reactions. And when we looked at this structure in those people who'd had a full night of sleep here in green, we saw a nice, controlled, modest degree of reactivity. Yet in those people who were sleep deprived, we saw this amplified, almost aggravated degree of reactivity. The amygdala was actually 60% more responsive under conditions of a lack of sleep. And it's almost as though without sleep we become all sort of emotional gas pedal and too little sort of regulatory control brake. But what is perhaps more concerning, however, is that this represents a neurological signature that is not dissimilar to numerous psychiatric conditions. And we're now finding significant links between sleep disruption and conditions such as depression, anxiety, including PTSD, schizophrenia, and tragically, suicide as well. In fact, we cannot find a single psychiatric condition in which sleep is normal. I think sleep has a profound story to tell in our understanding, in our treatment, and perhaps even may contribute to our ultimate prevention of grave mental illness. So that's sleep for the brain, but sleep is just as essential for your body. And here I could have gone into any one of the model systems and spoken about it in detail. We've already spoken a little bit about sleep loss and the reproductive system. I could tell you about sleep loss and the metabolic system. That after 1 week of short sleep, your blood sugar levels are disrupted so significantly that your doctor would classify you as being pre-diabetic. Or I could tell you about sleep loss and the cardiovascular system. That all it takes is 1 hour. because there is a global experiment that is performed on 1.6 billion people across 70 countries twice a year, and it's called daylight savings time. Now, in the spring, when we lose 1 hour of sleep, we see a subsequent 24% increase in heart attacks. In the fall, when we gain an hour of sleep, we see a 21% decrease in heart attacks. That is how fragile your body is to even just the smallest perturbations of sleep. I think many of us perhaps don't think anything of losing an hour of sleep. But as a deep dive, I actually want to focus on this, sleep and the immune system. And here I'll introduce these delightful blue elements in the image. They are called natural killer cells. Think of natural killer cells like the Secret Service agents of your immune system. They are very good at identifying dangerous foreign elements and eliminating them. In fact, what they're doing here in this image is embedding themselves into a malignant, a cancerous tumor mass, and destroying it. And many of you may not know, but today your body produced cancer cells. And it's always doing this. What stops those cancer cells from becoming the disease that we call cancer is in part these natural killer cells. So what you want is a virile set of these immune assassins at all times. And sadly, that's exactly what you don't have if you're not sleeping enough. So here in this study from my wonderful colleague, Mike Irwin, you're not going to have your sleep deprived for an entire night. You're simply going to have your sleep restricted to 4 hours for one single night. And then we're going to look to see what is the percent reduction in immune cell activity that you suffer. And it's not small. It's not 10%, it's not 30%. There was a 70% drop in natural killer cell activity. That's quite a concerning state of immune deficiency. And it happens quickly, essentially after just one bad night. Imagine the state of your immune system after weeks, if not months, of insufficient sleep. And it perhaps should then come as no surprise to learn that we now have significant links between short sleep and numerous forms of cancer. Currently, that list includes cancer of the bowel, cancer of the prostate, and cancer of the breast. In fact, the link between a lack of sleep and cancer is now so strong that recently the World Health Organization decided to classify any form of nighttime shift work as a probable carcinogen. In other words, jobs that may induce cancer because of a disruption of your sleep-wake rhythms. So you may have heard of that old maxim, you can sleep when you're dead. Well, I'm being absolutely serious. It is mortally unwise advice. Because if you adopt that mindset, we know from the data that you will now live a shorter life, and the quality of that shorter life will be significantly worse. Epidemiological studies teach us this. Short sleep predicts a shorter life. It predicts all-cause mortality. And the bad news, I'm sorry, keeps coming. Because if you are fighting a battle against cancer and not getting sufficient sleep, that cancer may grow more quickly and aggressively. So here I actually want to feature work not from my own sleep center, but by a scientist called David Gozal, who works at the University of Chicago. And he examines the relationship between sleep loss and cancer in mice. Now, I know this isn't for everyone, so I will tell you when to look away if you prefer not to see this. But in one of the studies that he did, he inoculated some mice with cancer cells on their back. And then he gave that cancer a 1-month period to grow. And at the end of that 1 month, he resected the skin and measured the size of that tumor mass. Half of the mice were allowed to sleep normally during that 1 month period. The other half had their sleep disrupted, not total deprivation. They just sort of played with them a little bit more during the day and during the night to restrict their sleep. So in a second, I'm going to play a video with David illustrating the results. Now would be the time to look away if you would prefer to do so. And here you can see him pointing to a mouse on a monitor with the skin resected, and you can clearly see that tumor mass there. This is in one of the mice that was allowed to sleep normally during that 1 month. I'll play the video and he will reveal behind it another mouse. That mouse was in the sleep restriction group, and you will see the difference in the tumor mass. This is the difference. There was a 200% increase in the speed and the size of that cancerous growth linked to insufficient sleep. Worse still, the cancer in those underslept mice had actually metastasized. That's just a medical description, meaning that it had breached the original origin and started to invade other areas, bone, other organs, as well as brain. When cancer becomes metastatic, that's when we see mortality rates escalate. So if you are fighting a battle against cancer and not getting sufficient sleep, it may be the equivalent of placing gasoline on an already aggressive fire. Sleep loss is an accelerant. And we now know that it produces a harmful biological fertilizer for the more rapid and rampant growth of cancer. Now, if increasing your risk of developing Alzheimer's or cancer by way of a lack of sleep were not sufficiently disquieting, we have since discovered that a lack of sleep will even erode the very fabric of biological life itself, your DNA genetic code. So here in this study, they took a group of healthy adults and limited them to 6 hours of sleep for 1 week. And then they measured the change in the gene activity profile compared to when those same individuals were getting 8 hours of sleep for a week. And there were 2 critical results here. First, a sizable and significant 711 genes were distorted in terms of their activity, caused by 6 hours of sleep. And that's relevant, by the way. We know that almost 1 out of every 2 American adults are trying to survive on 6 hours of sleep or less during the week. The second result was that about half of those genes were actually increased in their activity. The other half were actually decreased in their activity. Those genes that were decreased by a lack of sleep were genes related to numerous aspects of the immune system, which fits very well with the evidence I was just discussing regarding cancer. Those genes that were actually increased in their activity, or what we call upregulated in their expression, were genes related to the promotion of tumors, genes that were related to chronic inflammation within the body, and also genes that were related to stress and, as a consequence, cardiovascular disease. Now, I think many individuals in society feel uncomfortable about the idea of genetically modified embryos or even genetically modified food. But by choosing to get insufficient sleep, we may be forced to accept that we are performing a similar genetic modifying experiment on ourselves. And if we don't let our children get the sleep that they so desperately need, then we may be inflicting a similar genetic engineering experiment on them as well. There is simply no aspect of your physiology that seems to be able to retreat at the sign of sleep deprivation and get away unscathed. It's almost like a broken water pipe in your home. Sleep loss will leak down into every nook and cranny of your biology. Even tampering with the very DNA nucleic alphabet that spells out your daily health narrative. So where does this leave us? What is the piece of sort of mental furniture I would like to gift to you as we finish the talk? Well, it would be this. Sleep is not an optional lifestyle luxury. Sleep is a non-negotiable biological necessity. It's a life support system. And it is Mother Nature's best effort yet at contra-death. And the decimation of sleep throughout industrialized nations is having a catastrophic impact on our health, our wellness, and the safety and the education of our children. It's a silent sleep loss epidemic, and it is fast becoming one of the greatest public health challenges that we now face in the 21st century. I believe it is now time for us to reclaim our right to a full night of sleep. And without embarrassment. And without that terrible stigma of laziness. And in doing so, we may finally remember what it feels like to be awake during the day. And with that soapbox rant over, I will simply say good night, good luck, and above all, I do hope you sleep well. Thank you very much indeed. I think we've got lots of time for questions, I think.
I don't know if you can hear me, but thank you so much for the talk. It was actually very informative. I have two questions for you. Number one, I have a 5-year-old, and then there's myself, right? So how much sleep should we be getting? And number two, is there any disadvantage of oversleeping? So let's say if I sleep 10 hours, 15 hours in the day,
yeah.
Is there any disadvantage to that?
So great question. So firstly, recommendations for sleep, you can find them on the National Sleep Foundation website for all ages. For the average adult, the recommendation, World Health Organization, 8 hours, range 7 to 9. Once human beings, the average human being, gets below 7 hours of sleep, we can measure objective impairments. So people who say, I can survive on 6 hours of sleep, there's a problem with that, which is this. Your subjective sense of how well you think you're doing without sufficient sleep is a miserable predictor of objectively how you're doing without sufficient sleep. So it's probably a little bit like a drunk driver at a bar. You know, they've had 7 shots, they pick up their car keys and they say, I'm fine to drive. And your response is, no, I know that you think you're fine to drive, but trust me, objectively, you're not. The same is true for a lack of sleep. Your second question is fascinating. Can I sleep too much? Well, there are anecdotes of something called a sleep hangover, where you sort of oversleep, and then you feel worse almost. When you oversleep, it usually means that you're trying to sleep off a debt that you've lumbered yourself with. So if you could sleep past your alarm, if it didn't go off, then you're underslept because it's physiologically impossible to sleep too much if you're healthy. Now, there is one piece of evidence that suggests something called hypersomnia, excessive sleep. That principally expresses itself in depression. But if you look at that data, it's actually very difficult to tell. Is it people just reporting being in bed for longer rather than sleeping longer? So I think it's unclear right now. But let me just take it to a theoretical realm. Could there be such a thing as too much sleep? I think yes. But don't forget, the same is true for the other 3 essential factors of life: oxygen, food, and water. Can you eat too much? Yes. Can you overhydrate? Yes. Can you increase blood pressure, cause stroke and heart attack by excessive water intake? It happened in the 1990s with the ecstasy craze, where people were dehydrating. Governments told them drink lots. They drank too much. Cardiac events. Can you actually become hyper-oxygenated so you get free radical species, dangerous for cells? Yes, you can. Is there such a thing as too much sleep? We haven't found it yet, but I suspect probably so. It's a bell-shaped curve. It's a U-shaped function in terms of benefit, not linear. But are most people in danger of getting too much sleep? Au contraire.
Thank you for the great talk.
Thank you.
Do you also have any information on how quickly people recover after they switch from a kind of short sleep periods to kind of a more normal sleep period? Because you only mentioned kind of as one evidence was the DST change, when we sleep 1 hour more, kind of things get better in terms of cardiac problems.
Yeah.
But kind of, is it quick, the recovery as well, as quick as the downhill movement?
Yeah, it's a great question. So different aspects of your brain and your body seem to come back online to a status of health with recovery sleep. And those temporal profiles are different based on, even within the immune system, for example, some components take longer to come back online than others. What I would note, however, is that you can never get back all that you've lost. This is another one of those myths with sleep. So sleep is not like the bank. You cannot accumulate a debt and then pay it off at a later point in time, which is what most of modern society does. Chronic short sleep during the week, then you binge at the weekend. It's what I call sleep bulimia. It's what is otherwise known as social jet lag. Now, if I were to take you and deprive you of sleep for one single night, 8 hours of lost sleep, and then I give you all of the sleep that you want for however many nights, and we keep recording you, your brain never recovers all of that lost 8 hours. It will try to get back some of it. It will never get back all of it. Why is that the case, we can ask? Why doesn't your brain have a credit system for sleep? Because there's precedent for this in biology. You have one for energy. It's called a fat cell. You can actually store up credit calorically and spend it when you go into famine. Now, most of us aren't in that danger anymore, but during evolution, we faced that challenge, so we came up with a solution called the adipose cell. Where is the fat cell for sleep? Why isn't it there? The reason is this: human beings are the only species that deliberately deprive themselves of sleep for no apparent reason. What that means is that Mother Nature has never had to face the challenge through evolution of coming up with a safety net because of insufficient sleep. So there is no mechanism of safety. There is no credit system.
So similar to how we can take supplements after exercising, have you done any research about supplements that can help sleeping, well, without the device yet? And as a side note, what about melatonin?
So no drugs or supplements that we have currently produce naturalistic sleep. Chemically, it's an incredibly complex job. Now, I don't want to dismiss people at drug companies. I'm not against medication. I'm not anti all medication. If medications work, I'm all for them. It's just that all of the sleeping medications that we have right now don't produce naturalistic sleep. Most of them are a class of drugs that we call the sedative hypnotics. Sedation is not sleep. All you're doing is knocking the cortex out. You're not producing naturalistic sleep. And as I said, and I mentioned in the book, they are also linked to a higher risk of death, and it's considerably higher, as well as cancer. What about melatonin? Well, melatonin turns out not to be an effective sleep aid. And it shouldn't surprise us based on how melatonin works. Melatonin helps time the onset of sleep, but it doesn't help in the creation of sleep itself. So the analogy would be melatonin is like the starting official in the 100-meter race at the Olympics. Melatonin gathers all of the racers to the starting line and begins the race, but that official themselves does not participate in the great sleep race itself. That's a whole different set of brain mechanisms and chemicals. That's why melatonin is not efficacious once you're stable in a new time zone. Now, I will say this, however. If you're taking melatonin and you feel it's beneficial, keep taking it. Because the placebo effect is one of the most reliable effects in all of pharmacology. And that tells you something, by the way, something profound. There is such a thing as mind over matter, and there is now a wonderful science of the placebo effect. It's very real, and we dismissed it for a long time. I hope that answers both your questions.
Thank you.
Sure.
I was wondering, again, thank you for the talk.
Sure.
That does the time period between when you wake up to when you start using your brain for learning or whatever also play a difference? If a person had a full 8 hours of sleep, but they don't go to school until evening when they have evening school, do they learn worse than if they could have went to a morning school and start learning in the morning?
So it's a very interesting question, when on the clock face is learning, let's say, most beneficial? Well, once you're waking at a reasonable time, it seems as though there is some degree of stability of learning across the day. However, there does seem to be a gradual deterioration, and we've done some of these studies to basically map the time course, the Great Depression of learning, across the day. And we've inserted naps, and we can actually restore learning. But I would like to come on to naps. Someone should ask me about that, because they're a double-edged sword with danger. But what we do know from those school studies where they delayed the school start times, where you get the greatest grade point increases, is not in all classes across the day, but it's especially in those first morning classes. But I think that that's less about your brain being better at learning in the morning than it was about when you were starting so early, it was just so detrimental to try and learn. So you lowered the floor rather than raised the ceiling. But to me, it makes sense that learning is somewhat stable across 16 hours, because if you were to design a system of memory that could only learn in the last couple of hours of wakefulness, then why are we awake for the other 14? And we seem to have a system of memory that gives us a capacity for about 16 hours of recording in humans before sleep is required.
A quick follow-up question. Did you do any study on other brain activities like coding? Well, not coding, but more advanced stuff. Should I try not to schedule morning meetings because everybody is asleep and nobody's making decisions?
Yes. So we've done lots of studies on all aspects of brain cognition. We've done decision-making, judgment-making, we've done creativity, emotional regulation, we've done visual attention aspects, we've done motor skill learning, and it follows the same profile, which is essentially when sleep is in high volumes, all of those things are supported. Different operations within the brain rely on different stages of sleep at different times of night. However, it's not just one stage of sleep that does it all for all of your brain mechanisms and apparatus features. And this is why there is no single one stage of sleep that's important. People will say, oh, how can I get more REM sleep? And I would say, why do you want more REM sleep? Or how can I get more deep sleep? Mother Nature took about 3.6 million years to figure that out. Just let her do her job. She'll see you well.
Quick question, basically. How do drugs, any kind of drugs, medicine, alcohol, marijuana, how would it basically affect the brain activity during the night, during the sleep?
So how do drugs, perhaps some legal, some non-legal, impact sleep? I'll focus on marijuana and alcohol since you mentioned them. Alcohol is perhaps the most misunderstood drug when it comes to sleep. People say you have a nightcap and I fall asleep better. Untrue. Alcohol is also a class of drugs that we call the sedatives. And once again, that's not natural sleep. What you're doing is simply removing consciousness by way of alcohol. You're not putting yourself into natural sleep. Two more problems with alcohol. First, it will fragment your sleep with awakenings throughout the night. The problem is that they are so brief that you tend not to remember them and commit them to memory. So you wake up the next morning feeling unrefreshed, but you don't understand why, that it was the alcohol fragmenting your sleep. Finally, alcohol is very effective at blocking your REM sleep, at blocking your dream sleep. So alcohol, misunderstood, should be avoided. Marijuana, people use it to try and help them get to sleep or relax. The problem is marijuana also seems to fragment sleep. It also seems to block rapid eye movement sleep. Probably the other chemical that deserves mention here is caffeine. Caffeine, most people know, is an alerting drug. It's actually a class of drugs that we call the psychoactive stimulants. It's the only legal stimulant that we readily give to our children, by the way. Caffeine can obviously keep you awake at night, but some people will say, I'm one of those who can have a cup of coffee and I fall asleep fine. The problem there is that even if you fall asleep, the depth of the deep sleep that you have is not as deep as if you were to have sleep that didn't have caffeine swirling around within the brain. So again, you wake up the next morning feeling unrefreshed. You don't remember waking up or struggling to fall asleep, so you don't think it's the caffeine, but now you need 2 cups of coffee rather than 1 the next morning. You build up this vicious cycle, and it's probably the reason that caffeine is the second most traded commodity on the surface of the planet after oil. I don't think there's probably any other statistic that bears out how sleep deprived we are throughout industrialized nations.
Cool. Thank you. One more quick question. How much of the sleep every night is basically enough?
So
hours, maybe.
Once you, as I said, once you get below 7 hours of sleep, that's when we can measure objective impairments. Yep.
Thank you.
Yep. But that's once we can measure objective impairments. Doesn't mean that if we had more sensitive tools, we would measure it at 7 hours and 50 minutes.
I wondered about blue light exposure, especially from devices. And I back a couple of years ago, I got the blue light blocking glasses, and it does seem to actually give better sleep at night. I was curious what the research is behind that.
Yeah, that one is actually not a placebo effect, it turns out. So the studies are very clear right now. We are, as an industrialized set of nations, we are a dark-deprived society. And we need darkness because the way that darkness works is that it actually removes the brakes from the hormone melatonin that I described that needs to rise to help time the normal onset of healthy sleep. So if you're bathed in electrical light at night, even though it's not as powerful as daylight, it can keep the brake pedal on melatonin. Now, they did some fascinating studies where you read on an iPad for 1 hour versus just reading a normal book with dim light. And firstly, relative to that 1 hour of dim light normal book reading, the 1 hour of iPad reading firstly delayed that spike in melatonin by 2 to 3 hours. So here, if we were reading the iPad in Seattle, we're almost all the way to Hawaii in terms of our biological melatonin rhythms. That's how shifted and delayed we are. Second, the sleep was not as good. REM sleep was disrupted, and people subjectively felt worse and less refreshed the next morning. And it took a few days before it washed itself away after they ceased. So I think the recommendation right now is try to limit screen time in the last hour. I know where I'm speaking right now, which is at Google, and what that means. You can install software that helps desaturate the most harmful wavelength of light, which is the blue light. You can also put those spectacles on. They seem to work as well. But overall, try to decrease stimulation. Blackout curtains, also great at night, during the night, in bed.
Yeah, and a follow-up on the blackout curtains. One of the things I've found is it's really hard to get up in the morning if the room is all blacked out. Having that natural light come in is important. And I wondered which is worse, to have any of this light coming in during the nighttime versus having to deal with an unnatural alarm clock waking up in the morning?
Yeah, if you do have to, it sounds as though what you're experiencing is sort of a groggy, what we call a sleep inertia, which is when you wake up. It usually means that you're sort of waking up at a time that's slightly offset from your natural biological tendency. With that, you can use daylight to perhaps try and help you. Some people actually use eye masks in the first part of the night, and at some point they will take the eye mask off and then help with the exposure to the daylight because they've kept their curtains, non-blackout in that regard. But that's a tricky one to balance, yeah.
I know there are a lot of more questions. It's coming up on 2 o'clock, so we're going to cut it off. But Dr. Walker will stay, and he's going to sign books. We're selling a few of the copies. And so just everybody, let's give Dr. Walker a hand. And
thank you very much indeed. Thank you. Thank you so much. Thank you.